Hello, in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that AD is equal to BC. We also know that this angle ABC equals to 30 degrees. This angle ACB equals to 90 degrees. And we want to find out the value of this angle ADC. So we will start with the first method. First of all, we define side AC of triangle ABC as A, that is to say side AC equals to A unit in its length, and we will define side BC as B. So here side BC equals to B units in its length and I will present to you a new law that is actually the law of sines. The law of sines is true in any triangle, so we can write down that in any triangle, you can use it in any triangle. So if we have triangle ABC that could be any triangle, this is triangle ABC. We know that the length of side BC is equal to A units, and the angle here is angle A. We also know that the length of side AC is equal to B units, and the angle here is angle B. And we also know that this angle is angle C, and the length of side AB is C units. Then, according to the law of sines, A over sine A equals to B over sine B, and it equals to C over sine C, and it is true in any triangle. So from the law of cosine we can derive also that A over sine A equals to B over sine B, and we can implement the law of sine the lobe signs in our drawing. So I will draw triangle ABC in a new page, and we will implement the lobe signs in triangle ABC. So this is triangle ABC. And we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, this angle, if we define this angle as angle X, then in triangle ABC, we know that the sum of the angles must be equal to 180 degrees. That is to say, angle X plus 30 degrees plus 100 degrees must be equal to 180 degrees. Here we will subtract 130 degrees from this equation, and we will get that angle X equals to 180 degrees minus 130 degrees is 50 degrees. So we found out that angle X equals to 50 degrees. So we can substitute X by angle of 50 degrees. So this angle is equal to 50 degrees. And actually, we defined side AC as A, and side BC is defined as B. Then, according to the law of sines, if we implement the law of sines in triangle ABC, we will get that A over sine 30 degrees must be equal to B over sine 50 degrees, according to the law of sines. So here we will divide this equation number 1 by B, and then we will multiply it by sinus 30 degrees, and we will get that A over B equals to sine 30 degrees over sine 50 degrees. Okay, so according to equation number 1, we found out that A over B equals to sine 30 degrees over, it's actually sine 50 degrees here. Okay, so A, according to equation number 1, A over B equals to sine 50 degrees over sine 50 degrees. In the next step, I will draw triangle ADC in a new page, and we will implement the law of sines on triangle ADC also, this triangle. So, triangle ADC, this is triangle ADC. It is given us in the question that AD equals to BC. AD equals to BC. Okay, we know that AD equals to BC, but we defined BC as B. BC equals to B according to our definition. From this equation we will derive that AD also equals to B. AD equals to B. So here we know that this angle equals to 50 degrees. So if we define this angle as theta, then the other angle must be equal to 50 degrees minus theta, because of the fact that angle CAB equals to 50 degrees. So if this angle equals to theta, this angle must be equal to 50 degrees minus theta. And what is the value of this angle? Angle ADC that we are looking for. The value of angle ADC, if we define angle ADC as Y, then in triangle ADC the sum of the angles must be equal to 180 degrees. So here we have 50 degrees minus theta. In triangle ADC the sum of the angles must be equal to 180 degrees. That is to say, this angle is equals to 50 degrees minus theta plus this angle that equals to 100 degrees plus this angle that is angle Y. In total, those three angles must be equal to 180 degrees. I'll repeat again. In triangle ADC, the sum of the angles must be equal to 180 degrees. That is to say, 50 degrees minus theta plus 100 degrees plus angle Y must be equal to 180 degrees. Here we subtract 100 degrees from this equation and we will get that 50 degrees minus theta plus Y equals to 180 degrees minus 100 degrees is 80 degrees. We will subtract also 50 degrees from this equation and we will get that minus theta plus Y equals to 80 degrees minus 50 degrees is 30 degrees. And if we add angle theta to this equation, we will get that angle Y equals to 30 degrees plus theta. So we found out that the angle that we are looking for, that is to say, this angle that we defined as angle Y equals to 30 degrees plus theta. So we can write here that angle ADC equals to 30 degrees plus theta. And if we implement the law of sines in this triangle, triangle ADC, we will get that A over sinus 30 degrees plus theta will be equal to b over sinus 100 degrees. I'll repeat again. In triangle ADC, A over sinus 30 degrees plus theta will be equal to B over sinus 180 degrees. A plus sinus A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. We will divide this equation by B and then we will multiply it by sinus 30 degrees plus theta, and we will get that according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. This is according to equation number 2, but we have already found out that according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. So we actually can create equation number 3 that states that A over B, according to equation number 1, must be equal to A over B according to equation number 2. Okay? A over B according to equation number 1 must be equal to A over B according to equation number 2. A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and it must be equal to A over B according to equation number 2, that is to say, it must be equal to sinus 30 degrees plus theta over sinus 100 degrees. Here we will cross multiply equation number 3 and we will get that sinus 30 degrees times sinus 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Sine 30 degrees is 1 over 2, and we have the trigonometric identity that states that sine 2a equals to 2 sine a cosine a. So here sine 30 degrees is 1 over 2, and according to this trigonometric identity, the value of sine 100 degrees will be equal to 2 sine 50 degrees cosine 50 degrees. And it equals to sine 30 degrees plus theta times sine 50 degrees. So here we have sine 50 degrees in both sides of the equation, so sine 50 degrees will get cancelled, and 2 over 2 is 1. So in conclusion, we found out that cosine 50 degrees equals to sine 30 degrees plus theta. And we also have the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. We will use this trigonometric identity. According to this trigonometric identity, cosine 50 degrees equals to sine 90 degrees minus 50 degrees. That is to say, cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. So we can substitute here in equation number 3 cosine 50 degrees by sine 40 degrees. So we'll do it now, and we will get that cosine 50 degrees is sine 40 degrees according to this equation. And it equals, according to equation number 3, it equals to sine 30 degrees plus theta from the fact that sine 40 degrees equals to sine 30 degrees plus alpha. We will derive that 40 degrees equals to 30 degrees plus alpha. But 30 degrees plus theta. Again, 40 degrees equals to 30 degrees plus theta. We will subtract 30 degrees from this equation, equation number 3, and we will get that the value of angle theta, it is actually 40 degrees minus 30 degrees, the value of angle theta is 10 degrees. So we found out that the value of angle theta is equal to 10 degrees. Angle theta equals to 10 degrees, and the angle that we are looking for is angle ADC. Angle ADC equals to 30 degrees plus theta. The angle that we are looking for is angle ADC, and angle ADC equals to 30 degrees plus theta. And we already found out that theta equals to 10 degrees. That is to say, angle ADC equals to 30 degrees plus 10 degrees. That is 40 degrees. So we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. Okay? And we actually finished with the first method. The value of angle ADC is 40 degrees. Okay? We finished with the first method. In the next step, I will present to you how to find out the value of this angle, angle ADC, according to the second method. Okay, in the second method, we will do another construction from point A. First of all, we will extend side BC, and from point A, we will draw perpendicular to the extended BC. So, this angle, it is a right angle, it equals to 90 degrees, and this angle will be also a right angle. We will define the intersection point between the perpendicular from point A and the extended BC as point E. We know that we extended BC, that is a straight line, by a straight line. Therefore, line segment BE is still a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if this angle is angle X, we know that 100 degrees plus angle X must be equal to 180 degrees. 100 degrees plus angle X must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we look on the upper side of the straight line BE, then the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus angle X must be equal to 180 degrees. Here we will subtract 100 degrees from this equation, and we will get that angle X equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that angle X is equal to 80 degrees. So we'll substitute angle X by 80 degrees. We will define line segment AE as y, that is to say the length of line segment AE is y units, and we will define line segment CE as x. We will define BC as A. BC equals to A. BC equals to A units, but because of the fact that AD equals to BC, AD equals to BC, and we know that BC equals to A units, if AD equals to BC, we know that AD equals to BC, and BC equals to A units. Then from this equation we will derive that AD also equals to A units. AD equals to A units. And in the next step, we will focus on the right triangle, triangle ACE. This right triangle, small right triangle, triangle ACE. On the right triangle, triangle ACE, tangents 80 degrees, will be equal to AE over CE. I will repeat again. In the right triangle ACE, tangents 80 degrees will be equal to AE over CE. But AE equals to Y units according to our definition. So we will substitute AE by Y, and CE equals to X according to our definition. So we will substitute CE by Y, by X. C equals to X. So we'll substitute CE by X. Here we will multiply equation number 1 by X, and we will get that Y equals to X tangents 80 degrees. Okay? We found out that Y, line segment AE, that is Y, equals to X tangents 80 degrees. In the next step, we'll focus on triangle ADE, the right triangle, triangle ADE. On the right triangle, triangle ADE, we will define angle ADE or ADC as angle theta. So in the right triangle, triangle ADE, sinus theta equals to AE over AD. I repeat again. In the right triangle, triangle ADE, sinus theta equals to AE over AD. According to our definition, A equals to Y, so we can substitute AE by Y. And according to our definition, AD equals to A, so we'll substitute AD by A. So we found out that sinus theta equals to Y over A. Here we will multiply this equation number 2 by A, and then we will divide it by sinus theta, and we will get that A equals to Y over sinus theta. But according to equation number 1, Y equals to X tangents 80 degrees. Here, Y equals to X tangents 80 degrees. So we substitute Y in equation number 2 by X tangents 80 degrees, because Y equals to X tangents 80 degrees. Okay, so, and we'll get that according to equation number 2, A equals to Y. Y according to equation number 1 is X tangents 80 degrees, all divided by sinus theta. So actually we found out that the value of A, according to equation number 2, is X tangents 80 degrees over sinus theta. The value of A, that is actually AD and BC, equals to X tangents 80 degrees over sinus theta, and the value of Y, that is actually AE, is X tangents 80 degrees according to equation number 1. In the next step, we will focus on the right triangle, the right big triangle, triangle ABE. On the right, big triangle, triangle ABE. Tangents 30 degrees. Equals to AE over BE. I will repeat again. In the right triangle, triangle ABE, tangents 30 degrees equals to AE over BE. But AE equals to Y according to our definition, so we will substitute AE by Y. And what is the value of BE? From the drawing, you can see that BE, you can easily see that BE equals to A plus X, okay? BE equals to A plus X. So we will substitute BE by A plus X. So according to equation number 3, tangents 30 degrees equals to Y over A plus X. Okay? But according to equation number 1, Y equals to X tangents 80 degrees. So we'll substitute Y in equation number 3 by X tangents 80 degrees. And according to equation number 2, A equals to X tangents 80 degrees over sinus theta. So we'll substitute A in equation number 3 by the value of A that we found in equation number 2. So we'll do it now. In conclusion, we'll substitute Y and A by the values that we found for them in equation number 1 and equation number 2. And we will get that tangents 30 degrees equals to Y is X tangents 80 degrees according to equation number 1 over A according to equation number 2 is X tangents 80 degrees over sinus theta plus X. So here we will multiply X by sinus theta, and then we will divide it by sinus theta in order to have a common factor with this expression. So it is actually X sinus theta. As you already know, X sinus theta over sinus theta is X. So if you multiply something by a variable, and then you divide it by the same variable, you change nothing. That is the reason that this operation is allowable. We actually multiplied X by sinus theta, and then we divide it by sinus theta, so we change nothing. Okay. So here we will move sinus theta that is in the denominator to the numerator. Okay, and we will get that tangent 30 degrees equals to x tangent 80 degrees times sinus theta over x tangent 80 degrees plus x sinus theta. So here we have x in the numerator and we have x in the denominator, so we'll cancel x. Okay, x will be cancelled because we have x in the numerator and in the denominator also. And we will get that, and we also know that tangent 30 degrees is 1 over square root of 3, and it equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta So here we will cross multiply equation number 3 and we will get that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta. Here we will subtract sinus theta from this equation, equation number 3, and we will get that according to equation number 3, in this side of the equation we left with tangent 80 degrees. That will be equal to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Okay, so here we will take out sinus theta as a common factor. On this side of the equation number 3, we will take sinus theta as a common factor, and we will get that tangent 80 degrees equals to, so we took sinus theta as a common factor on this side of the equation. Inside the brackets, what is left here is square root of 3 tangent 80 degrees, and here we took sinus theta as a common factor, so what is left here is minus 1. Here we will divide this equation number 3, by square root of 3 times tangent theta minus 1, and we will get that sinus theta equals to tangent 80 degrees over square root of 3 tangent 80 degrees minus 1. Okay? We know that sinus, the value of sinus is sine theta is, the value of tangent theta is sine theta over cosine theta, and the value of tangent 80 degrees is sine 80 degrees over cosine 80 degrees. So we'll substitute tangent 80 degrees by sine 80 degrees over cosine 80 degrees in this equation number 3, and we will get that sine theta equals to tangent 80 degrees is sine 80 degrees over cosine 80 degrees, and all divided by square root of 3. Again, tangent 80 degrees is sine 80 degrees over cosine 80 degrees. And there we will substitute minus 1 by minus cosine 80 degrees over cosine 80 degrees. Minus cosine 80 degrees over cosine 80 degrees is minus 1. That is the reason that it is allowable to substitute minus 1 by cosine 80 degrees over sine 80 degrees. So here we have cosine 80 degrees in the numerator and cosine 80 degrees in the denominator. So cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees? What is left is it is actually according to equation number 3, we will get that sine theta equals to sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. Here we will multiply the denominator on this side of equation number 3 by 2, and then we will divide this by 2, and we will get that sine theta equals to sinus 80 degrees over, again we will multiply equation number 1 by 2, and then we will divide it by 2. So it is 2 times square root of 3 over 2 times sine 80 degrees minus cosine 80 degrees over 2. We divided equation the denominator by 2, and then we multiplied by 2, so we change nothing. It is cosine 80 degrees over 2 so we got that according to equation number 3, sine theta equals to sine 80 degrees over 2 times, we know that square root of 3 over 2 is cosine 30 degrees, so we'll substitute square root of 3 over 2 by cosine 30 degrees, and we'll get that sine 80 degrees minus cosine 30 degrees. Again, square root of 3 over 2 is cosine 30 degrees minus cosine 80 degrees, and 1 over 2 is sine 30 degrees. So we will substitute 1 over 2 by sine 30 degrees. Okay? And here we have the trigonometric identity that states that sine sine A minus B equals to sine A cosine B minus sine B cosine A. So according to this trigonometric identity, we will get that the value of sine 80 degrees cosine 80 degrees minus sine 30 degrees cosine 80 degrees equals to sine 80 degrees minus 30 degrees. Again, according to the trigonometric identity, that sine A minus B equals to sine A cosine B minus sine B cosine A, we will get that sine 80 degrees cosine 30 degrees minus sine 30 degrees cosine 80 degrees equals to sine 80 degrees minus 30 degrees. That is actually sine A minus B. So according to equation number 3, we found out that sine theta equals to sine 80 degrees over 2 times sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees. So I write it down. We got that according to equation number 3, sine theta equals to sine 80 degrees over 2 sine 50 degrees, because of the fact that 80 degrees minus 30 degrees is 50 degrees. Here we will use the trigonometric identity that states that sine 2a equals to 2 sine A cosine A. According to this trigonometric identity, we will get that sine 80 degrees equals to 2 sine 40 degrees cosine 40 degrees over 2 sine 50 degrees. Okay, so we found out that sine theta equals to 2 sine 40 degrees cosine 40 degrees over 2 sine 50 degrees. 2 over 2 is 1, so 2 will get cancelled. And we also have the trigonometric identity that states that sine theta equals to cosine 90 degrees minus theta. So according to this trigonometric identity, we'll get that sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. So sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. So we'll substitute sine 50 degrees in this equation, equation number 3, by cosine 50 degrees, by cosine 40 degrees, because sine 50 degrees equals to cosine 50 to cosine 40 degrees. So according to equation number 3, we will get that sine theta equals to sine 40 degrees times cosine 40 degrees we found out that sine 50 degrees equals to cosine 40 degrees. So we will substitute here sine 50 degrees by cosine 40 degrees. So we have here cosine 40 degrees in the numerator and cosine 40 degrees in the denominator, so cosine 40 degrees will get cancelled, and we actually found out that sine theta equals to sine 40 degrees okay. Theta is the angle that we are looking for. You can see we are looking for angle theta, that is actually angle ADC. Okay? So according to this equation, sine theta equals to sine 40 degrees, we will get that theta equals to 40 degrees. Theta equals to 40 degrees. So we found out that angle ADC that equals to theta is equal to 40 degrees. Okay? So actually this angle theta equals to 40 degrees according to the second method. We found out also that according to the first method, angle theta equals to 40 degrees. So now I will summarize the lecture. Actually, we wanted to find out the value of angle theta, that is actually this angle ADC. We found the value of angle theta in two different methods. In the first method, we use the law of sines in order to find out the value of angle theta. Here, what is the law of sines? The law of sines is true in any triangle. In any triangle, if we know that this is triangle ABC, that could be any triangle, the length of AB is C units, the length of side AC is B units, and the length of side BC is A units. According to the law of sines, A over sine A equals to B over sine B equals to C over sine C. From this formula we can derive that A over sine A equals to B over sine B, and we implemented the law of sines in our drawing. Here I draw triangle ABC. It is given us in the question that angle ACB equals to 100 degrees, angle ABC equals to 30 degrees, and we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, the sum of the angles in triangle ABC must be equal to 180 degrees. It means that angle X, this angle, that is angle X, plus 30 degrees plus 100 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we got that 180 degrees minus 130 degrees is 50 degrees. So we found out that the missing angle is equal to 50 degrees. Angle BAC equals to 50 degrees. Here we implemented the law of sines in this triangle, triangle ABC. According to the law of sines, A over sine 30 degrees, A over sine 30 degrees must be equal to B over sine 50 degrees. Again, according to the law of sines, A over sine 30 degrees must be equal to B over sine 50 degrees. This is equation number 1. Here we divided equation number 1 by B, and we multiplied it by sine 30 degrees, and we got that A over B equals to sine 30 degrees over sine 50 degrees. Again, according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Okay, then I drew triangle ADC, this triangle in a new page. This is triangle ADC. Actually, we defined BC as B, AC as A. So, according to our definition, BC equals to B, and it is given us in the question that AB equals to BC, and according to our definition, BC equals to B. So, from this equation, we will derive that AD also equals to B. So AD equals to B, and AC equals to A. According to our definition, AC equals to A. And we found out that AD equals to B. And here we found out the value of the missing angle that we are looking for. Here we have already found out that angle CAB equals to 50 degrees. Angle ABC equals to 50 degrees, but angle DAC equals to, so here we know that angle CAB equals to 50 degrees. Okay, so if we define this angle, angle BAD as theta, we know that angle CAB in total is equal to 50 degrees. So angle CAB that equals to 50 degrees minus angle theta will be the value of this angle, that is actually angle CAD. That is to say, angle CAD will be equal to 50 degrees minus theta. That is to say, angle DCAD will be equal to 50 degrees minus theta. So this angle equals to 50 degrees minus theta. Okay? And we know that the sum of the angles in any triangle is equal to 180 degrees. So the sum of the angles in triangle ADC must be equal to 180 degrees. So this angle that is actually 50 degrees minus theta plus this angle that is 100 degrees plus the size, this angle that we defined as angle Y must be equal to 180 degrees. It is true in any triangle, and especially in triangle ADC. So here we subtracted 100 degrees from this equation, and we got that 50 degrees minus theta plus y equals to 80 degrees. We subtracted 50 degrees from this equation, and we got that angle minus theta plus y equals to 30 degrees. We added theta to this equation, and we found out that angle y equals to 30 degrees minus theta. So the angle that we are looking for in this question that is actually angle ADC equals to 30 degrees plus theta. Then we implemented the law of sines in this triangle, triangle ADC. According to the law of sines in triangle ADC, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. I'll repeat again. In triangle ADC, we know that A over sinus 30 degrees plus theta, A over sinus 30 degrees plus theta equals to B over sinus 180 degrees. Again, A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. We divided this equation number 2 by B, and then we multiplied it by sine 30 degrees plus theta, and we got that A over B equals to sine 30 degrees plus theta over sine 100 degrees. So according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. But according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. So we can create equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So equation number 3 states that A over B according to equation number 1 equals to A over B according to equation number 2. A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and it must be equal to A over 2 to A over B according to equation number 2. And A over B according to equation number 2 is sine 30 degrees plus theta over sine 100 degrees. Here we cross multiply this equation number 3, and we got that sine 30 degrees times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. We use the trigonometric identity that states that sine 2a equals to 2 sine a cosine a in order to find out the value of sine 100 degrees. Here we have sine 30 degrees is 1 over 2. And sine 100 degrees is 2 sine 50 degrees, cosine 50 degrees according to this trigonometric identity, and it equals to sine 30 degrees plus theta over sine 50 degrees. Here we have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And what is left from equation number 3 after we cancelled sine 50 degrees? What is left is actually here cosine 50 degrees equals to sine 30 degrees plus theta. Okay, but we have the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. So cosine 50 degrees according to this trigonometric identity will be equal to sine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. So here we actually can substitute cosine 50 degrees by sine 40 degrees because of the fact that cosine 50 degrees equals to sine 40 degrees. Okay, so we substituted cosine 50 degrees by sine 40 degrees, and we got that sine 40 degrees equals to sine 30 degrees plus theta. So from this equation, sine 40 degrees equals to sine 30 degrees plus theta, we will get that 40 degrees equals to 30 degrees plus theta. Here we subtracted 30 degrees from this equation number 3, and found out that angle theta equals to 10 degrees. So here angle theta equals to 10 degrees, and the angle that we are looking for is angle ADC that equals to 30 degrees plus theta. So 30 degrees plus theta that equals to 10 degrees, is 40 degrees. So we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. Okay, so we finished with the first method. Then I presented to you how to find out the value of angle ADC according to a second method. In the second method, we did a construction. We extended side BC by a straight line, and from point A we drew perpendicular to the extended BC, and we defined the intersection point between the perpendicular from point A and the extended BC as point E. So this angle is 90 degrees and this angle is 90 degrees. And actually we know that we extended the straight line BC by a straight line. So BE will be still a straight line. And if we focus on the upper side of the straight line BE, we have the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. That is to say 100 degrees plus this angle, that is angle X, must be equal to 180 degrees. 100 degrees plus angle X must be equal to 180 degrees. We subtracted 100 degrees from this equation and we got that angle X equals to 80 degrees. So we found out that this angle equals to 80 degrees. Then we focus on this right triangle, triangle ACE. On this right triangle, tangent 80 degrees equals to AE over AC. On triangle ACE, tangent 80 degrees equals to AE over CE. AE equals to Y according to our definition. CE equals to X according to our definition. A equals to Y according to our definition, C equals to X according to our definition. So we found out that tangent 80 degrees equals to Y over X. We multiplied this equation by X and we got that that Y equals to X tangent 80 degrees. According to equation number 1, Y, that is actually AE, equals to X tangent 80 degrees. Then we focused on the right triangle, triangle ADE. We defined this angle that we are looking for as angle theta. Angle ADE that we are looking for defined as angle theta. So here we know that sinus theta equals to AE over AD. In the right triangle, triangle ADE, sinus theta equals to AE over AD. AE equals to Y according to our definition. AD equals to A. AD equals to A. Because of the fact that BC equals to AD and BC equals to A, so AD will be also equal to A. So we found out that according to equation number 2, sinus theta equals to Y over A. Here we multiplied this equation number 2 by A, and then we divided it by sinus theta, and we got that A equals to Y over sinus theta. And according to equation number 1, Y equals to X tangent 80 degrees, so we will substitute Y by X tangent 80 degrees, and we got that A equals to Y, that is X tangent 80 degrees over sinus theta. So according to equation number 2, A equals to X tangent 80 degrees over sinus theta, and according to equation number 1, Y equals to X tangent 80 degrees. Then we focus on the right big triangle, triangle ABE. On this right big triangle, triangle ABE, we know that this right triangle, triangle ABE, we know that tangent 30 degrees equals to AE over EB. Again, on the right triangle, triangle ABE, we know that tangent 30 degrees equals to AE over BE. According to our definition, AE equals to Y, and BE, you can see from the drawing that BE equals to A plus X. Okay, BE equals to A plus X. So we found out that tangent 30 degrees equals to Y over A plus X, that is BE. tangent 30 degrees equals to y over a plus x. According to equation number 1, we know that y equals to x tangent 80 degrees. Here, y equals to x tangent 80 degrees. And we have already found out that a equals to x tangent 80 degrees over sinus theta. So we substitute y by x tangent 80 degrees, and we substituted a by x tangent 80 degrees over sinus theta. And we also have to add x. And in order to have a common factor with this expression, we multiplied x by sinus theta and then we divided by sinus theta. So we changed nothing. And here we moved sinus theta that is in the denominator to the numerator. And we got that x tangent theta times sinus theta equals to x tangent 80 degrees plus x sinus theta. Here we have x in the numerator and we have x in the denominator, so x will get cancelled. And we found that tangent 30 degrees is 1 over square root of 3. That equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we cross multiply this equation number 3, and we found out that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees times sinus theta. Here we subtracted sinus theta from this equation number 3, and we got that tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sin theta minus sin theta. Here tangent 80 degrees equals to, we took out a common factor sinus theta out of this expression, and inside the brackets in this expression what is left is square root of 3 times tangent 80 degrees, and what is left from sinus theta after we took sinus theta as a what is left from minus sinus theta after we took sinus theta as a common factor, what is left? It is actually minus 1. Okay, so we got this expression. Then we divided this equation number 3 by square root of 3 tangent theta minus 1. And we got that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. We know that tangent 80 degrees is sinus 80 degrees over cosine 80 degrees. So we substitute the tangent 80 degrees by sine 80 degrees over cosine 80 degrees. And here also tangent 80 degrees equals to sine 80 degrees over cosine 80 degrees. And we got this expression. Here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator. So cosine 80 degrees will get cancelled, and what is left after we cancelled cosine 80 degrees, what is left, it is actually sine theta equals to sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. Here we multiplied the denominator by 2 and then we divided by the denominator by 2. So we got here 2 times square root of 3 over 2 sine 80 degrees equals to cosine 80 degrees over 2. 2 over 2 is 1, so it is allowable to divide anything by 2 and then to multiply it by 2, so because we changed nothing. And we got that sine 30 degrees, sine 80 equals to sine theta equals to sine 80 degrees times 2 sine 80 degrees, and square root of 3 over 2 is cosine 30 degrees, so we substituted square root of 3 over 2 by cosine 30 degrees, and we also minus cosine 80 degrees over 2, so it is minus cosine 80 degrees, and we substituted 1 over 2 by sine 30 degrees, because sine 30 degrees equals to 1 over 2. And we got that sine theta equals to sine 80 degrees, and this expression sine 80 degrees cosine 30 degrees minus cosine 80 degrees sine 30 degrees is actually according to the trigonometric identity that sine A minus B equals to sine A cosine B minus sine B cosine A. This expression will be equal to sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we substitute this expression by sine A minus B. A is 80 degrees and B is 30 degrees. So this expression equals to sine 80 degrees minus 30 degrees according to this trigonometric identity that sine A minus B equals to sine A cosine B minus sine B cosine A. Okay? Then we used the trigonometric identity that sine 2A equals to 2 sine A cosine A in order to substitute sine 80 degrees to 2 sine 40 degrees cosine 40 degrees, and here 2 and 2 will get cancelled, and according to the trigonometric identity that sine theta equals to cosine 90 degrees plus theta, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine sine 50 degrees equals to cosine 40 degrees. So we can substitute here sine 50 degrees in this equation number 3 by cosine 40 degrees because of the fact that sine 50 degrees equals to cosine 40 degrees. So we substituted in the equation number 3 sine 50 degrees by cosine 40 degrees, and we got that sine theta equals to sine 40 degrees times cosine 40 degrees over cosine 40 degrees. Cosine 40 degrees over cosine 40 degrees is 1, so it will get cancelled. And we got that sine theta equals to sine 40 degrees. So we found out that angle theta equals to 40 degrees. So here angle theta, the angle that we are looking for is angle theta, and we found out that angle theta equals to 40 degrees. That is to say the angle that we are looking for, that is actually angle ADC, that equals to angle theta equals to 40 degrees. So in both methods we actually found out that the value of angle theta or angle ADC equals to 40 degrees. Okay? Again, we found out that the value of angle ADC that we are looking for, the value of this angle is equal to 40 degrees in both methods. Okay, thank you very much.